NAT back. The idea was that all you had was a shell connection, a text interface to the internet, but there was this awesome new stuff, Mosaic. Not even Netscape yet, Mosaic. And you didn't have Win95. No, it was all about the trumpet WinSock in the house. And how were you going to get trumpet WinSock to talk to your shell account so you can Mosaic to see some porn? How were you going to do that? Well, thus, the Slurp shows up and basically says, all right, I got an account here. It lets me open sockets. I got a client here. It gives me a stream of packets. I'm going to parse the stream of packets, and I am going to create a series of socket connections. Creating a series of socket connections. This sounds familiar. So there was a Linux PPTP daemon called PopTop. It's still around. PPTP, for the love of God, don't learn it. It's the most hideous thing on the planet. But you can think of it as it takes all the streams coming out of your box. They get turned to packets. It takes these packets, encapsulates them, sends it to that guy over there. Just imagine, here's a stream of packets containing all your outbound TCP connections, and UDP even as well. So what you would do back in the day was you would use PopTop, VPN in, connect to Slurp, and Slurp was actually completely external. The entire PPP side was external. So with the SSH era, what I would do was, instead of running Slurp locally, I'd SSH 5,000 miles away and run Slurp over there. And now instead of VPNing into, the machine over in my room, I'd VPN to, some machine 5,000 miles away. Works really well. Well, Slurp was designed to handle its socket connections directly. You would tell it, please open a socket to 1.2.3.4, and it would do it all by itself. Well, what if we had a browser that was willing to open socket connections for us? Could we use Slurp to turn the packets back into streams and then pass those packets out to IE? Could we connect Slurp to IE? Why, yes, and that's why the software is called Slurpee. So the general idea, the attacker's running an application that uses sockets. The sockets get their traffic sent over PPTP to Slurp. Slurp provides a set of streams to the proxy. The proxy tells the browser's bucket, open these some sockets. The browser opens the sockets, which provide some sockets. The proxy mediates the traffic between the attacker's sockets and the browser's sockets, and it all just works. You don't need to write some SQL client in JavaScript. No, you can just use SQL Explorer. You want to run Nessus over IE? You got Nessie. You want to run World of Warcraft over IE? You got WoWie. Any TCP-based protocol will just work. And if you want to mess with Firefox or Safari, you get UDP too. Impacts. Well, corporate firewalls are bypassable via LERD browsers. Your home routers are at exceedingly high risk. For the love of God, go home, change the default password on those things. We had a whole era of attacks of people blindly attacking the home routers with cross-site request forgery. People are like, aha, what you need to do is you need to make it so that the browser needs to be able to read your response. Right now they're blind. They're just sending stuff in. You need to make the browser find a cookie and repeat it back to you. Well, now, with this attack, browser totally sees the cookie. Your home routers are not in good shape. And neither, I guess, are your corporate routers if they have web interfaces. Every browser is a proxy. There are lists out there that you can buy that contain all the proxies in the world. There's not that many, and then you just decide not to trust them. Now, you don't need proxy servers. You don't need a botnet to bounce off of. Every browser is a spammer. Every browser can send SMTP. Every browser can go ahead and do click fraud. Every browser can link to your instant messenger server. Every browser can proxy click fraud. This sucks. $1 billion was lost by Google to click fraud. The idea is that there are sites out there that will pay an immense amount of money for a click. Like, oh, you got a click for some disease that they're kind of sort of suing the pharmaceutical company over. You get a click from someone who might actually join a class action. It's like $10. So people will just create fake identities. Now these fake identities have been tracked by looking at the IP addresses. But now any browser can be used to be these fake identities. It sucks. So there are a bunch of other attacks possible. Stealth Tor, you can just be kind of sort of silently joined to the Tor network. Oops. Do stuff to protect neutrality. There's some peer-to-peer networking issues. Java's giving us UDP. UDP is symmetrical. You could actually have an entire cloud, a peer-to-peer cloud of browsers that are talking to each other, no servers involved, and there's no special code that gets deployed on the client. There's just Java. There's a little bit more. This was a joke. In fact, IP over spam was not just a joke. I was smashed. I'm over at DEF CON doing the TCP/IP drinking game, and I am asked the question, how would you get around the Great Firewall of China? Now, the right answer to this question was, go ahead, drop all the reset packets, and ignore the firewall trying to shut you down. See also how to get around Comcast. How are we at a situation where China and Comcast are doing the same thing? Dear God! But you see, I'm smashed. And so I'm like, no. Watch. China sends a crap ton of spam. China receives a crap ton of spam. Let's go ahead and encapsulate all of our IP traffic in Viagra spam. It's perfect. It's high bandwidth. It's low latency. There's tons of masking noise. You've got like 50,000 other servers that are making you invisible. This is perfect. And people laughed, and I laughed, because I would never actually think of building this. And then I look at this hack. I'm like, well, I kind of have IP inbound, and I kind of have the ability to send spam outbound. Dear God, I was joking. All right, so can we fix this problem? So check it out. Flash, I've talked to some of the Adobe guys. They're going to fix the worst of their issues. Arbitrary TCP from Flash is going to go away. In fact, actually, just to clarify, Flash does not have arbitrary UDP. That's an error on the slide. Java, I have not heard a word from Sun. I'm not saying that maybe I should or shouldn't have. I'm just saying I don't know what Sun's up to, but you know what? They don't work in IE. Browsers themselves, where you use an iframe or you use MSXML or you use any of these other things, yeah, we're probably doomed. I don't want to be doomed, but yeah, we're probably doomed. First off, we have to detect that there's a cross-IP script. Remember, cross-IP scripts are legitimate, though. Google does it all the time. Yahoo does it all the time. If you break it, you break the web. Funny thing in security, you're not allowed to break the web. People have tried. So let's say you actually detect that there's a cross-IP script going on. What do? Well, people are using this stuff. Theoretically, you could have Google and Yahoo and CNN and all these sites opt their addresses into some sort of, yes, this address is part of the Google land. This address is part of Yahoo land. This is great. But how do we enforce that? When can we say so many people have gone ahead and shifted over that we can go ahead and make the browsers enforce it? You know what? That's like a 4-year thing, 5-year thing, maybe. So, yeah, even if we could snap our fingers and say there are highly motivated server providers that want to shift over, we still have all these old browsers that are just going to need to continue to be supported. It sucks. And all those old browsers are going to be vulnerable. So here are the mitigations that people talk about. One that they talk about a lot is host header checking. The idea is same origin policy was indeed broken from the start. They screwed up, and they can't fix it in the client. So what they'll try is, all right, we screwed up the client. Let's have